So in this video, let us study about the redundant branches and combinations. So if in a circuit, there is a branch that is not carrying any current, that means the current is not flowing through that particular branch or the combination of elements, then that combination of resistances or that branch, it can be considered inactive from the circuit point of view. So that means, see here, if there is a voltage source, now we have a resistance here, then we have a resistance, okay, then we have a short circuit like this. So what happens, the current, it always chooses that path where it has less resistance. And in the case of short circuit, the resistance is actually zero, means it is offering no resistance for the current flow. So what happens, the current that is flowing here, it takes this path. So it does not flow through this resistor R2. So it takes this path. That means this branch or this element, that resistor R2, it is not carrying any current. So there is no current flow through this resistor. So it becomes redundant in the circuit point of view. It becomes redundant. So I can consider this circuit like this. So I can eliminate this from the circuit. But remember, while calculating the power, you should not consider this as redundant because there will be some effect in the power calculation. Okay. So this is called as redundant because across this we have a short circuit. So we can also consider another type. There is a voltage and we have combination of resistances. And here we have a short circuit across these two resistors, R2 and R3. So this combination of resistance now becomes redundant because the current here, it takes the path of this short circuit because it is offering zero resistance. So it does not follow this path. Okay. So the current which is flowing here will be now zero. So this combination of resistance, they do not carry any current. So R3 and R4 combination of resistances can be considered as redundant. So redundant is actually, it is like excessive or it is unwanted So it happens, first case is when there is a short circuit across a resistance or the combination of resistance. In the second case, if you have an open circuit, so if it is open somewhere like this, see you have R2 here, then you have R3, okay, then we have R4. If we have an open circuit, what happens? What will be the current? Current will be 0 ampere because the condition for the current, that is open circuit, that is current is equal to 0, resistance is equal to infinity, and there will be some voltage drop across the open circuit. So here the resistance is infinite, so the current doesn't flow. It opposes the flow of current. And here the current is equal to 0. That means here also it is 0. So we can consider these two branches. If it is like A, B, C, D, E, F, then this B, C and C, D branches, okay, this becomes redundant. So we can redraw like this. We can neglect these two resistances now. That becomes redundant. So if we have another case, here also there is open circuit. That means current flowing here will be equal to 0. That means this combination of resistances, it can be considered as redundant. So if there is any short circuit across resistance or combination of resistances, or if there is open circuit, then they can be considered as redundant. That means unwanted or excessive.